Okay. All right. So yesterday we were looking at derivatives of two things. We mainly focused on logs, right? We're mainly focused on logs, but in fact, not even like logs. We're mainly focused on natural logs, right? So today we're going to look at the others. All right. So anytime we're doing, these are the steps that we're going to follow. Anytime we need to find derivative of a log. Okay. So let's see where we left off here. Let's see. Okay, so we skipped these two. These two are ones that we skipped earlier because we're still doing natural log. So in the middle of all those problems, there's these two here. They say example 1 and example 2, but they're not in order. I cut and pasted from different sources, so that's why some of them say example 1, some of them say example 2, and then it jumps. Okay. Okay, so these are E, right? E to some power, right? We have the power is as an x, the exponent has a variable, so it's an exponential, and even more so than that, it's a exponential with E. Okay, so our directions say anytime we have that, it's going to repeat itself. So whatever it is, it's going to the derivative is going to repeat itself. And then we multiply times the derivative of whatever power it is. Okay. So let's go back here. So if I'm finding the derivative of this guy, okay, it repeats itself. So it's going to repeat e to the 2x minus 1 times, and then you're going to take the derivative of the power. What's the derivative of the power? 2. Most of the time you won't see it that way. Most of the time you'll see it like this. Oops. That's how you'll see it most of the time. Okay. This guy over here. Now, before I start example number 2, what should I do? What do you see that we've seen in the past that would help us to change to find the derivative? Before we start the derivative process, what would help us? Anyone see anything? Okay, so let's start. Repeats itself, e to the 3x, or sorry, 3 over x times, and then how am I going to find the derivative of the top? How am I, or sorry, the derivative of the exponent? How am I going to find the derivative of the exponent? Because that's what I got to do next, right? You can use a quotient rule, absolutely. Yeah, it's a fraction, so you can use the quotient rule. That works. What's another way of doing it? Not chain rule. I think you're close. Yeah, quotient rule. Yeah, Isabella said quotient rule. That works. Quotient rule's a little long though, right? It works. It works. If you want to do it, it works. But there's something that would make it a little shorter. That's what I was thinking. What I was thinking is at the original, that's what I was saying. Does anyone want to change it? Because our next step was find the original or find the derivative of the exponent, right? And I kind of saw it coming down the road that, hey, we're going to have to find the derivative of that guy. You can use quotient rule. Quotient rule will work, right? Low d high over high d low over low squared. You could do that for this guy. That would work. But quotient rule is pretty long, right? So the only time we want to use quotient rule is when we have no other choice. Okay, but like I said, it will work. If you're on a test and you're like, and you do a quotient rule on there, you'll be fine. Okay, you will be fine. So instead of that, now what I'm going to do is I'm going to find the derivative of this guy right here. So for this guy, I could just use power rule. I can just use power rule. Move the -1 to the front. That makes a -3. X to the -2. It's a lot easier than using quotient rule. But again, quotient rule will work. Okay. We have a negative exponent. So I got to change that. I'm going to move this to the front. Oops, -3x² times e to the 3 over x. That's a perfectly fine answer. If you want to, you could combine them. To make that too. Either one of those are perfectly fine answers. If the exponential, you see the exponential is a fraction, we're going to leave it like that. Because if we change it, it's going to have a negative exponent, and that's not good either. So we just leave it like that. Okay, it's our only option is to leave it like that. Okay. All right. Okay, so let's skip ahead to the next one. All right, let's do these guys now. Couple slides over. Okay, so these are still exponentials, but they're not e-exponentials. They're not e-exponentials. Okay, so let's see. Let's go back to what our directions say. Our directions say, first thing we got to do is find the natural log of a. What is a? Not x. Look where a is and look where a is. This is our problem right here. Right here, this is our problem. So the one you're looking at right now, what is a? 2. Yeah, a is 2. And what is u? X, right? So everywhere you see an a, that's a 2. Everywhere you see an x, that's or u, that's an x. Okay. So now it's going to be the natural log of 2 times 2 to the x power repeating itself, right? Times the derivative of x, which is 1. Yeah, that's it. That's it. Okay. So what we said was first thing, natural log of the base times repeat itself times the derivative of the exponent. So we have 2 to the x times the natural log of 2. Now the natural log of 2 is a number. The natural log of 2 is it's a number, right? The natural log of 2 means e to what power equals 2. It's a number. Okay. But these are non-calculator questions. Okay, so if it's a non-calculator question, we just leave it as natural log of 2. We just leave it in its exact form, right? If I use my calculator, then I have to round the answer because this answer is a decimal. Okay, so just leave it like that. Okay. All right, so if you haven't already, do the next one. 3 to the x power. Okay, so natural log of the base. So natural log of the base, so dy dx equals natural log of the base, so natural log of 3, which is about 1 point something, times repeat itself times the derivative of the base, or the exponent. So 3 to the x times the natural log of 3. Okay. Let's see, we skipped that one. Let's see, we're kind of jumping around here. I'm trying to find some problems that we've looked at. Let's look at this one. Let's find this one. It's towards the end. Okay, so we got to find the derivative of f of x. Okay, so f prime. We have e to a power plus 6 to a power plus the natural log of secant squared x. Now this guy looks ugly. It looks very ugly, and that's where these types of problems get you. They get you even before you start, because you look at it and you're like, these are ugly. How am I going to do this problem? Just like we just did the ones before, right? This problem is really 3 separate problems, right? Because of that plus, these are 3 separate problems. Okay, so let's treat it like 3 separate problems. Let's not look at it like one problem. Let's look at it like 3 problems. And then just at the end, we'll put them together. So the first thing is e to the tangent of 3x. I'm going to put the angle in parentheses. I always put the angle in parentheses just because it's good practice. Okay, sometimes you'll see textbooks or on tests they won't do that. I always do it just because it's, like I said, it's just good practice. So you keep it separate so you know what the angle is. Okay, so what did the direction say to find the derivative of that guy? What did the direction say to find derivative of this guy? Mm-hmm. Yep. Start with itself. It repeats itself. It always repeats itself. Anytime it's e to any power, first step, repeat itself. So if you see something on a test where it's e to some power and you got to find the derivative, look for the one that repeats itself. There will always be a few that don't repeat themselves. Those are not going to be the answer. The one, it has to repeat itself. Okay, so it's got to repeat itself. That's the first step. And then what do? Find the derivative of the exponent. Yep, this guy here, which we've done before. So the derivative of this guy right here, how are we going to do that? What are we going to use to find derivative of tangent 3x? The chain rule. There you go, the chain rule. This is the outside. What's the derivative of tangent? Secant squared. Secant squared, everything stays the same, times the derivative of the inside, which is this guy right here, which is just a regular 3, right? Done. That part is done. Okay. So let's clean it up so it looks a little nicer. Where you put the 3 in the front, that's the coefficient. You can put the secant squared. It doesn't really matter where the rest of it you put. Okay. I can switch these guys up. I can move these guys, switch these guys around. That doesn't matter. The 3 usually is in the front because that's the coefficient. That part is done. We're going to put it to the side. Next one. Next one is six to the x squared. power. 6 to the x squared power. Okay, so what do our directions say for finding derivative of that guy? What's the first thing we're going to do? We just did these. What's the first thing we got to do? The natural log of the base. The base is 6. Natural log of 6. Good. Times. Starts repeat itself. There you go. Repeats itself. 6 to the x squared. Good. What's the last step? Derivative of the exponent. The derivative of x squared? 2x. Done. Let's move the 2x to the front. Everything else we'll keep like that. Let me highlight them so that we know where we're looking. That one and that one so far are the ones that we want. Last one. Natural log secant of x. So this is what we did yesterday. So is this a product rule or is this a chain rule? Chain rule. It's not product rule, right? What are we finding the natural log of? Secant, right? It's embedded in there. Okay, so it's a chain rule. Okay. So what if we're finding derivative of a natural log? All right, this is the outside. What does the derivative of the natural log say? Mm-hmm. Exactly. The derivative of whatever we're finding this guy goes on top. Whatever this is goes on the bottom. Okay. So on top, we're going to find the derivative of secant. What's the derivative of secant? Secant tangent. Yeah, secant tangent. It repeats itself and then tangent, right? So that's going to go on top. Secant x, tangent x. And what's going to go on the bottom? Secant x. Good. Where am I at? Yeah, where am I? Sorry, I lost my place. Here we go. Okay, so we found the derivative. So the derivative for a natural log is, we said it was going to be the derivatives on top. So secant x over, no wait, derivatives on top, right? Secant x tangent x over secant x, right? Are we done? No, we just found the outside. That was the derivative of the yellow, right? So now we got to chain the derivative of the inside. So the derivative of the inside is secant x. So what's the derivative of secant x? Secant x tangent x. Okay. So this is a lot of secant x tangent x on top. This is just one on bottom. So what can we do to simplify? Can I do this? Yeah, I can. Yeah. Why can I do it then here, but other problems I couldn't do it? Because it's straight multiplication, right? It's straight multiplication everywhere. There's no additions or subtractions. That secant x is not +1, +10, minus something. Same thing with this guy here, right? So let's multiply straight across. I got a secant x times two tangents, tangent squared of x. Oops, not let me do that. Do that. Okay, done. Put them all together. How am I going to join them together? What's going to go? What am I going to do when I join them together? Plus, yeah, just that addition sign in between them. Addition sign in between them. So I would have f prime of x. Since it's addition, order doesn't matter, but we'll do the first one first. So the first one was this guy right here. Plus the next one was right here. Plus, and then the last one was right. Oops. Okay. Got a long, ugly answer, but again, if you do it by pieces, it's not so bad. And you just combine what you have. Okay. Okay, so I want you to do this one here. Do the one right underneath it. Give you about 5 minutes to do that one. Do this one right underneath it. Okay, so I've done the first two up here, so you can, I didn't do the last one yet. I'm gonna do that right now, but I did the first two, so you can take a look at yours. The ones highlighted are my answer. So just follow the process. If you're finding derivative of e to any power, it repeats itself times the derivative of the power. If it's an exponential that's not e, like 7 to the 2x, first thing is the natural log of the base times repeating itself times 2. Sometimes it's easier to think of repeating itself first. So sometimes you'll see these two guys switched. This, in our textbook, they have it as the natural log first and then repeating itself. In other textbooks, it has you repeating itself first because it's easier to remember, right? Anytime it's an exponential derivative, repeat itself. So you could put this first. Okay, sometimes it's easier to remember it that way. So any exponential, if you find derivative, it's going to repeat itself. So if you're looking at, these will be multiple choice questions. They won't be free response questions. So if you're looking at multiple choice questions and it wants you to find a derivative of any exponential, look for the one that repeats itself. Okay, boom, that's going to be it. If there's only two that repeat itself and the other two don't, those aren't going to work. It's only the ones that repeat themselves. Okay. So little things like that, little tricks like that can help you whittle down your answers so that you can just focus on the ones that could be right. Okay. And then natural log, when we do derivative of a natural log, right? That's going to be the derivative of whatever we're finding that natural log goes on top. So in case this is going to be 2x, and then it's just going to repeat itself on the bottom, right? And that's it. Okay. So since this one wasn't a chain rule, it was just natural log of something. That's what we do. Okay. Put them all together. The grand answer . Oops, it's not negative. There's one of them. Plus the second one. Plus the last one. Done. Okay, yes, sir. For the natural log of x, for the natural log? That's a good question. So let's think of other problems that we've done. Let's look at other problems. Yeah. The best way to answer that question is to look at other problems. So let's look at some other natural log problems here. Let's see, we did a whole bunch yesterday. Doesn't that kind of look like that guy right there? Right? And that's what we did, right? So wait, so the last problem, I think we did wrong. I think we did too much on the last problem. Let's go back to the last problem. Let me double check that we didn't make a mistake. I think I might have went a little overboard on the last one. Okay, so the last one here, we found the derivative of secant here. I don't think we need this guy over here. Did we? Like this? Let's see. Number 11. 10. Oh, okay. I see why. I see why you're saying this one's different because it was a cosine was on the outside. So this one was different. Yeah, this one was different because cosine was on the outside. Natural log of something isn't. So if we have natural log of something, so if I have a natural log of anything, natural log of x squared plus 8, that's not a chain rule problem. That's just a natural log derivative problem. Okay. Now, if I have something like this, natural log of the square root of x squared plus 8, that's a chain rule problem because on the inside I have a power, right? So yeah, it's kind of getting used to that because the line with, is it a chain rule problem or not? This guy is a chain rule problem, 100%, because cosine is its own thing. And then natural log of x is its own thing. But this guy right here, how about that one? It's a bad example. I think I skipped it. This guy right here is not a chain rule problem because it's the natural log of this guy here. So that's what I was saying. I think this part over here that we added, I don't think is needed. So let's take that off. So it's just going to be tangent. One tangent. So over here, just one tangent. Can I get carried away there? Okay. Okay, so let's do something like this. Okay, so sometimes it's easier when you're doing, so find this, it's a little bit before where we were. Sometimes when you're doing log derivative problems, sometimes it's easier to use these. You guys learned about these in math 3. It's one of the last things we do in math 3 before we move to trig. It's one of the last things. It's called, they're the log properties. There are 3 log properties. You got a multiplication property, product property, quotient property, power property, okay? So it says we can rewrite them. So if I have a natural log of something times each other, I can break them up by addition, giving them each a natural log and adding them. Same thing here. If I have a division, I can break them up by giving them each a natural log and subtracting them. Here, if I have a power, I can move that power to the front and it becomes a coefficient. Now, you don't need to use these rules, but it might help you make it easier. For example, if we have something that looks like this, when I find the derivative of the inside, I'm going to have to use product rule, right? Over here, I'm not going to have to. 2 small problems that I just add together like we did, right? Make the problem smaller. Over here, I would have to use quotient rule to find the derivative of this, right? Because when we find natural log, right, the top is the derivative and the bottom repeats itself, right? Well, here, I would have to use quotient rule. Over here, I wouldn't. I would just find the derivative of the top, find the derivative of the bottom, subtract them, and you're done. A little easier. Over here, I would have something to a power. And imagine if that power was like 2 to the x, then I would have to do derivative of that, which is longer process, right? So instead of that, what it says is you can move it to the outside and becomes a coefficient. You don't have to use these rules, but I put them on there because sometimes it'll make your life a lot easier. if you do it this way. Okay, so let's look at this guy here. The one right after, number 13, even though I don't think it's number 13. Okay, so it's a natural log of something. So we're going to use the natural log rules, right? So the natural log, so anytime we have a natural log, right? Natural log of anything, we take the derivative of that, put it on top. Whatever was on there to begin with, we put on the bottom, right? That's what we do. Now look at the inside here. Look at the inside of this guy right here. How would I find the derivative on top? Or how would I find the derivative that goes on top? What would I need to do? Product rule, yeah, I would have to do product rule. Now, what the log rules say is, you don't have to do that. You can do it this way instead. Give this guy a log, a natural log, and then plus give this guy a natural log. Since it's multiplication on the inside, you can do it that way. Now, this guy right here looks a lot easier to solve than this guy right here. Just because natural log of x is just 1 over x. Natural log of sine, the derivative is cosine over sine, you're done. This guy over here, though, we're going to have to use product rule. Again, you can do it, okay? I'll do it both ways if you want me to, and show you that you get the same answer, okay? So let's do it the direct approach. Direct approach first means product rule, okay? So y prime okay. So the derivative of the top, derivative of the inside goes on top. Well, that's going to be a product rule, right? So product rule says the first times the derivative of the second plus the opposite. The derivative of the first times the second. And then this would go on the bottom. And then I would simplify that. X times cosine of x plus sine of x over x times sine of x. Okay. Can I cross out these x's? No. Because of that plus here, I can't cross out these x's there. Be careful. There's a lot of x's here. There's one's here, one's here, one's here, one's here, one's here. Sometimes if you see a lot of them, you start doing that. You cannot do that. First of all, these guys here, that's why I always do this. Those are protected, right? So the only ones that don't are this guy and this guy. But because of this here, it won't work. Okay. All right, so let's do it using the log rules. Okay, so natural log of x plus the natural log of x over sine of x. Derivative 1 over x plus cosine of x over sine of x. Done. Look at our two answers. The two boxes are our two answers. They're supposed to be the same. They don't look the same. Why aren't they the same? Yeah, the common denominator, right? I would have to get them to be exactly the same. They are the same. But to get them to be exactly the same, I would have to find a common denominator here and here, right? What is the common denominator and add them together? What was the common denominator between x and sine of x? Oops. This guy right here, right? So I would need a sine of x over here, and I would need a x over here. So you see how this guy gets an x because I would put an x here and an x there. And then this guy needs a sine of x. And so you see how this guy gets a sine of x over there. Okay. So here's the thing. They're not going to give you both on a multiple choice. They're only going to give you one or the other. More than likely, it'll be this guy here. So if you do it using log rules, that's fine. But then if you do this, you get this as an answer. You're like, whoa, whoa, whoa. Mine doesn't match any of them. Mr. Flores, I think this question's wrong. I get that a lot. Mr. Flores, I think this question's wrong. No. Okay. So you got to be able to, if needed, like on the quiz, the quiz wasn't multiple choice, right? The quiz was only free response. And this is what happened. A lot of you got answers like this and then try to put them together. And when you did that, you didn't do it correctly. So the answer was even more wrong. I didn't take off any points. I said I did this. I did one of these. I crossed out the wrong stuff and I boxed in the correct stuff. Okay. And I said full credit. I'm not going to do that on the test. Okay. So if this is a multiple choice question, match it to one of the answers. If it's not, leave it like this. Okay. Don't dig a hole that's even deeper to get out of. Okay. Leave it like this. Go on to the next problem if it's a free response problem. Okay. You don't need to do any, because I could tell a lot of you guys got an answer and then you tried to force something that wasn't there. So you went from having a correct answer to something that was wrong. Anything that's on the paper, I have to grade. So if it's a wrong, even though you had it right here, I can give you some credit, but because you kept doing stuff here, I have to mark that off. So I have to take off a point. I didn't do that on the quiz. Like I said, on the quiz, I didn't do that. I just looked for the right answer and I stopped. But AP rules say anything on the paper, we have to grade. Okay. So unless you crossed it out, if you personally cross things out on the paper, I can't read it. I can't grade it. Okay. So you don't have to erase it. A lot of you like erase everything. You don't have to do that. If you don't want me to read something or you don't want me to grade something, just cross it out or put a line through it and say, don't read that. That means I can't grade it. Okay. So if this is a free response question, leave it like this. If you do it log rules, leave it like this. If you do it the direct way. Okay. The only time we need to combine things like this is on multiple choice when that answer doesn't match A, B, C, D. Then we start looking at, okay, so how do I get common denominator and stuff like that? You don't need to do that if it's not asked, okay? Even though I'm saying it right now, I can already say on the next test, there could be people try to do that. And on the test, I'm gonna have to mark it wrong. Even if you had the right answer, I'll mark on your paper, you got the right answer, but all your other stuff made your points go down. Instead of 3 points, you got 2 points, okay? So free response, just get in, get out. Get in, get out, free response. Multiple choice, you try to match it to one of the ones that are there, okay? All right, so one more problem. Let's do one more and then we'll be done. Let's do this one here, number 15. Okay, so before when we start the problem, what's the most daunting part of this problem here? What's the part that kind of gives you pause? The fraction, yeah, I would say the fraction, right? Natural log, we've done that, right? Derivative of what's on the inside goes on top. Whatever was there already goes on the bottom. Done, right? Besides that, the fraction is what gives me pause, right? So it's a quotient rule, right? You can do quotient rule. So you got to do quotient rule on top. It repeats itself on the bottom. You have a fraction over a fraction, and then you're going to have to simplify, right? You can do that. Now look at this problem here. Gone. No fraction. Just a subtraction sign in the middle. This one looks a lot easier to do than the one you just saw, right? Guess what? They're the same problem. Okay. So using some of those rules helps. It only works if it's a natural log. So if it's a natural log of something and it's a division or multiplication, you can do that. Okay. So I don't think I have time to do it if I did it the other way. So I'll do it the shorter way. So we have x squared. So 2x over x squared minus 3 over 3x minus 2. Done. Okay. Now, if you did it the other way, I know you'd have an x squared times a 3x minus 2 on the bottom. That would be your common denominator, right? You could do it that way. Okay. It's not wrong. It just takes you a little longer to do it. Like I said, because you'd have to do on top, you would have to do, wait a second, I'm not done. Okay. I know how to do this problem. I'm trying to help you guys. Okay. This you would have to do on top, right? Because the derivative. So this stuff here, you would have to do the derivative on top. So that would go on top. And then on this would go on the bottom here. X squared over 3x minus 2. So you'd have a fraction over a fraction. Then you would need to change flip to make it into 1, so you could do that as well. Okay, I'll do that in the notes right now. I'll add it to the notes that I post online, but you could do that as well. Okay. All right. So I'm going to assign there's going to be an assignment in Google in Delta Math. I'm going to assign it today. It won't be due till Tuesday. It's going to be dealing with this. We're not done with this, but I at least want you to do some practice on your own. There's still a couple things I want to talk about on here that we haven't gone over. Okay. And then there's 2 more things we need to cover for derivatives, and then we'll be done with this chapter. Okay. So next week, we're going to finish the chapter. Probably won't have, I'm trying to decide. I don't know if we're going to have I got to decide about tests. Either end of next week, week after will be a test. Okay. So just make sure you look at Google Classroom. All right. Okay. Now you guys get back up.